Welcome to ATT&CKcon Power Hour, probably the only 90-minute hour you're going to experience today. I'm your host and lead of MITRE ATT&CK, Adam Pennington. If you aren't familiar with MITRE, we're a not-for-profit dedicated to solving problems for a safer world. Through our public-private partnerships and federally funded research and development centers, we work across government and with industry to tackle some of the world's biggest problems. If you're here, you've probably heard of ATT&CK. With ATT&CK and ATT&CKcon, we're working to bring communities together to improve cybersecurity. ATT&CK is open and available to any person or organization for use at no charge globally. I want to start by thanking everyone who submitted to our open CFP process for ATT&CKcon over the summer. Similar to the past two ATT&CKcons, this year was very competitive and resulted in the monthly ATT&CKcon Power Hour sessions we have scheduled through January. I'd also like to thank the ATT&CK team and everyone out there who's contributed to ATT&CK and works to make ATT&CK better. A couple quick housekeeping notes as we get started. Along with your link to today's session, you should have also gotten a Slack invite. In that Slack, you'll find channels dedicated to each talk. Please ask any questions you have for today's speakers there in the channel dedicated to their talk. Our ATT&CKcon interviewer, Jamie Williams, may ask your questions live, or the speaker will have an opportunity to answer it in Slack after their talk. Today's session is being recorded and will be posted online and sent to all registered participants once we're done editing and captioning the videos, hopefully early next week. So without further ado, I'm going to turn over to the first speaker of the first ATT&CKcon Power Hour, Brian Donahue from Red Canary.
Hello. Got a bit of a lag on, there we go. All right, so first off, thank you, Adam. Thank you to the ATT&CK team for organizing this conference and for allowing me to come and speak at it. Apologies in advance if my talk gets interrupted by any dogs barking or the pitter-patter of toddlers running flat-footed above my head, but such is the reality of life in 2020. So without wasting any more time, my talk is starting over with sub-techniques, and it's about the lessons that we learned at Red Canary when we remapped from the old pre-sub-techniques version of MITRE ATT&CK to the new sub-techniques version of ATT&CK. So before I go any further, a few things about myself. I work at Red Canary. I primarily either support publication of content or work on it myself. Importantly, in the context of this talk, I am one of the lead writers of our threat detection report, which is an effort to gather all of the threats we detect in our customers' environments and sort of rank and stack the MITRE attack techniques associated with them for the purposes of determining which attack techniques are most prevalent and creating sort of a ranking order to them. Prior to joining Red Canary, I've worked as a journalist and as a CTI analyst. About 10 years ago now, I was interviewing for a job as a social media editor at ThreatPost. It would have been my first job. It was my first job. The editors there asked me, have I had any experience with social media? I lied. I told them I did, when in fact I did not. They either believed me or didn't care, but they hired me. And that's how my career started here. So if you dislike me or my talk, you can send your hate mail to Paul Roberts and/or Dennis Fisher. Now that I've got that out of the way, so we've already gone through who I am. I'm going to give you guys just an absolute bare minimum background on what Red Canary does so that you can sort of understand the context around our remapping effort. Then we'll run through the 7 lessons we learned, and then we'll close with a minute or two of question and answers. So one of the primary things Red Canary does is manage detection and response. So we gather telemetry from our customers' endpoints. We parse that telemetry against some thousand of detection analytics to surface potential threats. Then those potential threats are reviewed by a human on our detection engineering team. That detection engineer can either suppress or hide that event, or they can confirm that it's a threat, in which case they ship what we call a confirmed threat detection to a customer. For the purposes of this talk, that's effectively a customer notification. It's more than that, but for our purposes, just understand that it includes, among many other things, the MITRE attack techniques that threat is corresponded with. So given the way our system operates, we have a few different options for how we can handle attack mapping. We can do it at the behavioral analytic or the detector level. The benefit of doing it at that level is that it's highly scalable. You get to make your mapping decisions when you write your detection analytic. So you make that decision once and it's automated from there on out. The problem with that is that it's bad at nuance. So you might have a theory about what your detection analytic is going to catch, and then in practice, it might catch something altogether different. A second option would be to do this at the detection level. So if we go back that last slide, the detection level would be at this human analysis level. The benefit of doing it at the human analysis level is that it is good at nuance, right? You've got all of the context you need to make a determination about what MITRE attack technique is associated with it. However, it's difficult to scale because it slows down your detection pipeline because you have to make a decision and choose from 200 some odd techniques every time you detect a threat. The third potential option is like the why not both option. And I'm actually going to get into that later on in this presentation. So we actually map at the analytic level. So we make the determinations about what our analytics, what technique they should map to, like when we're developing them. And the reason we do this is because primarily Red Canary exists to detect threats. So when we adopted MITRE attack a few years ago, we made the decision to optimize for threat detection and speed, since oftentimes we're detecting things of high priority rather than like being 100% accurate in our mapping all the time. So what this looks like in practice, the red text at the top here is a detection analytic. It basically is looking for a process that is an LTest, and that also includes a command line with domain trusts or all trusts. This maps to domain trust discovery. And it's basically a technique that adversaries use to make determinations about domain trusts within an environment. This is irrelevant for the purposes of this talk, but historically, this detector has helped us catch a whole lot of trickbot activity. So now that you understand sort of this high level background, the first lesson that I'd like to impart on you is like, if you're going to map things, or if you're going to transition from old MITRE to sub techniques, like the first thing you need to figure out is all of the things that you were mapping to MITRE attack in the first place. So for our purposes, that would include behavioral detection analytics, which I already sort of explained. It would also include atomic red team tests. So atomic red team is an open source adversary simulation platform that we manage and maintain. And all of the tests in it are designed to simulate attack techniques, and they're mapped to attack techniques. For the purposes of this talk, you can kind of think of these two things, the behavioral analytics and the atomic tests, sort of interchangeably, because like the atomic tests are isolated scripts that map to attack and simulate behaviors. The analytics are isolated bits of Ruby code, also mapped to attack, designed to catch techniques. We also map a lot of our research and educational content to MITRE attack, but like a lot of it is derivative of our detection. And we didn't go back and retroactively map any of it. So that didn't really involve any upfront work. For your purposes, you might be mapping threat intelligence reporting to MITRE attack. You might have like charts and tables that you're using to determine things like detection coverage, or like any variety of security controls, alerts, IOCs, and the like. Oh. So, sorry, having some issues here. So, once you figure out what you need to map to attack, it's time to do the actual mapping. Sorry, I'm having a little bit of trouble controlling the screen right now. All right, there we go. So first things first, well, I guess it's the second thing. So let the code do the work for you, okay? So luckily, MITRE attack created a useful little JSON crosswalk script. And effectively what that'll tell you is like it'll tell you like what a technique remaps to. So maybe a technique becomes a parent technique and it'll tell you the sub techniques under it. Maybe a technique becomes a sub technique and it'll tell you the parent technique above it, or possibly the technique, if it's like scripting, has just deprecated. So we took that JSON crosswalk script, we built a little PowerShell script that sort of helped it work specifically with our environment. And like for Atomic Red Team, we kind of naively thought that the code would do all the work for us. We were quickly disabused of that notion. For the behavioral analytics, as I'll get to in a minute, we sort of knew that we were going to have to do a good deal of manual review there. So once you get to the point where you realize that you're going to have to do a human review at some level, you have to make a choice of whether or not you want to divide and conquer or do it as a small team or individual. So the benefits of doing it as a team, obviously, are that it will get done faster, although it might get done faster at the cost of it being less consistent. The benefit of assigning it to an individual or a very small team is that it might be more consistent, and then the cost of that might be that it takes longer. So if you have a reasonable number of things you need to remap, then by all means, keep it to a small team or an individual. However, for our purposes, we've got thousands of active detection analytics. We've got 500 plus atomic red team tests. And like, I don't even know how many, but there's some like 200 plus attack technique and sub-technique combos. So that was just too much work for any individual to do. So we assembled a team consisting of our intelligence team, our threat research team, our detection engineering team, and most importantly, not me. So all credit goes to those three teams. I stood back and watched and asked a lot of questions and wrote a blog about it eventually. So I stole this quote from my colleague, Katie Nichols, but attack mapping is an art. It's not a science. So particularly if you're going to have a team that's doing this work, you should create a style guide because people interpret techniques in different ways. And a style guide, like the other thing to remember is that we're kind of learning this on the fly, right? Like these sub techniques are new. So a style guide will help us learn like how to map things. It will keep some guardrails on how we map, and it will help enforce consistency. Equally important is to assign a review team. So we assigned a team of senior detection engineers and intelligence analysts to review every single mapping decision that was made by the broader remapping team. This also helped to enforce consistency, and it helped us catch errors that we may have made in the mapping process. Lesson 5, find and fix your legacy mapping issues. So I'm going to tell a little story. So when we were working on the threat detection report, like the first thing we do is we pull the data and we see, and we make a pivot table and we see like, what are the top 10 MITRE attack techniques from last year? The initial data poll revealed that masquerading was the top technique. So we then went and we made a sub list of the detectors that converted to a threat that was mapped to masquerading most often. And these two detectors showed up. The first one looks for untrusted binaries spawning suspicious Windows service hosts. The second one identifies SVC host executing with a suspicious parent process. All told, these two detectors on their own or in conjunction with one another triggered on more than 4,000 confirmed threats. However, when my colleague and our principal intelligence analyst, Jeff Felling, went and reviewed all the individual detections associated with those two behavioral analytics, he made a startling discovery. He discovered that those two analytics actually were representative of process injection and not of masquerading. So we manually remapped them. We ran the numbers again. We also manually remapped a few other analytics, but they weren't nearly as dramatic as these ones. And process injection fell to number 1, and then masquerading became number 6. So this is a great lesson. Like, this is the perfect time to review your behavioral analytics. Also, probably good to be reviewing them on a continual basis just to make sure that nothing changes over time. Lesson number 6, considering the alternatives. So I promised you that there was a third sort of why not both option for where we could do our attack mapping. And here's where I'm going to talk about that. So again, mapping at the detection level is the most accurate. Mapping at the analytic level is the fastest. However, we're developing an idea called conditional mapping. We haven't really operationalized it yet, but the idea is that we're going to try and identify ambiguous analytics. Maybe they're just broad, maybe there's some sort of other problem going on, but the idea is like you pick out the ones that don't always alert on the thing you hypothesized they would alert on, and then you require a human review of those. So you're still able to keep the main benefit of mapping at the analytic level because most of the mapping is going to get done there. So you still have the speed, and then you just identify that small subset of problematic detectors and you require a human review of them. Now, the 7th and final lesson is just to have fun with it, guys. Just kidding. That's not the 7th lesson at all. The seventh lesson is actually, the lag's back, to give back to the MITRE ATT&CK community. So the ATT&CK team is constantly looking for feedback. They probably get less of it than they need. So ways you can give back. Obviously, the most obvious way to give back is probably to contribute techniques back to MITRE ATT&CK. But I think also like they want feedback on what's working and what's not working. And by all means, you should reach out to them and let them know, suggest improvements and whatever else you can think of. Finally, like if you learn something while using ATT&CK that might be useful to the rest of us, write a blog about it or give a talk about it. And then while we're on the topic of blogs, I know that I only had 14 minutes here and I'm talking incredibly fast like a madman. So if you want to take more time with this talk, we wrote a blog version. Matt Graber and Katie Nichols and I wrote a blog version of this talk maybe a couple weeks ago. The link is right there. I'll try to remember to tweet it after this talk if any of you follow me on Twitter. And I guess without further ado, we can sort of jump into the Q&A.
That was fantastic, Brian. Thank you. That was really great. Like I said, I really appreciate, coming from the ATT&CK side, we did so much work to kind of produce and publish these sub-techniques. So we are really excited to see like an organization as large as Red Canary adopt it and actually make it their own. Like you said, I love the quotes coming off that blog, the art of this, as well as all of the nuance. So definitely, I've seen a lot of traction and kind of activity going around about your talk. So definitely stay queued up for some questions. But one thing I just wanted to ask you was, you kind of mentioned how kind of artistic and free spirited this mapping is. And one of the things I was wondering is, do you think that as advice to other organizations, is this an all or not effort, or can you map certain portions to sub techniques and then maybe stay behind in other areas? You mentioned how like nuanced Red Canary is with, Atomic Red Team and detections, as well as looking at the matrix itself. Like, do you think there's areas to carve that up, or do you think it's a binary yes or no kind of question?
Yeah, so I think that I'm interested in talking to other organizations about this because I actually think that like in a weird way, Red Canary is like designed to be mapped to MITRE ATT&CK. And I think that there's a lot of people that would have a lot of a harder time with that. Like specifically if you're doing like a lot of IOC and signature-based stuff, I can see how it would be difficult to map things to ATT&CK. And also if like you're dealing with a lot of alerts that maybe are false positives, then I could also understand how that could be a problem. But yeah, for us, like the Atomic Red Team stuff and the detection analytics really teed us up to have like a relatively easy job of mapping to ATT&CK.
Yeah, tracking. Thank you. And thanks again. Excellent talk. Like I said, I think the experience and wisdom that you guys have got kind of leading the way and doing that mapping is really greatly appreciated and, big benefits to the community. So thank you. But with that, I think we're right on time to turn it over back to Adam for our introduction of our next speaker.
Great. Thanks so much.
Yeah, thank you, both Jamie and Brian. So next up, we have a team from Temple University. We have Anshul Rege, who's an associate professor there, along with PhD student Rachel Blyman. So take it away.
Great. Hi, everyone. My name is Anshul Rege. I'm an associate professor with the Department of Criminal Justice at Temple. And I'm here today with my amazing graduate research assistant, Rachel Blyman. And today we want to share with you how we are using pre-attack and attack in the social sciences for cybersecurity and cybercrime education and research. We want to thank MITRE for the opportunity to let us share what we're doing with you all today. And of course, we want to thank our funders, the National Science Foundation, because without them, we couldn't do what we're doing today. So on the agenda, we're going to talk about how we're using pre-attack for cybercrime and security education. Rachel is then going to share with you how we've been using attack for some of our research data sets. And then we're going to end with a summary and talk about where we'd like to go with what we're doing in education and research. So let's get started with that first component. How are we using MITRE pre-attack framework in security education? I teach a cybercrime course in the social sciences. The emphasis here is on the human aspects of cyber attacks and security, with an emphasis within that on social engineering. The class is composed of students from multiple disciplines. So we have not just social science students, but we also have computer science and engineering students. We've grouped them up in about 8 different groups that have both social and computer science students in them. The objectives of one of the assignments that they have is we're trying to map the pre-attack framework to social engineering case studies to help students learn how these frameworks can be used to conduct threat intelligence, but also to understand the limitations of both the case studies and the frameworks. So we've got about 6 social engineering case studies with a lot of details, and students will be required to look at the overall mapping to the pre-attack framework, the specific expansion on certain tactics and techniques that they find, and then identify mitigation strategies identified in the framework and also extend beyond that. This was our first attempt this semester to try something like this, but we're hoping to learn and grow in this. So students, like I said, we're going to be given 6 different case studies. Within each case study, they would then map it all to the overall framework, as you can see by the highlighted boxes here. So if they find certain components, they would map it on. But then the idea here is we want them to think about things like, what is the proportion of mapping? How much of the case study were you able to successfully map onto the framework? Because then this gets them to think about the implications. What does this mean for the case study, right? Do we see certain patterns? Can we identify if certain tactics and techniques are useful? And of course, then what are the implications for pre-attack, in the sense that how well does it apply to social engineering? Now, we're aware that pre-attack is going to be restructured and possibly merged with attack, but this is what we're doing in the fall semester. We'll be adapting this project moving in the future. So once they've done this overall mapping, they then have to zoom into a specific tactic and try to identify things along the lines of techniques, similar techniques that fall under that tactic to, again, identify relationships, see if they can come up with any detection measures as identified in the framework, and of course, dive into the difficulty level for the adversary. But in addition to this, we want them to think about mitigation for social engineering. So currently, if you look at MITRE's attack website, under mitigations, they have mitigations listed for enterprise and mobile. And we are trying to get our students to think about, well, what would something similar look like for pre-attack, for social engineering? What would be those mitigation strategies? And if none exist, students are then encouraged to recommend mitigations. And these might take the form of, for instance, policy or training and awareness, right? Moving beyond that technical domain. So the overall then objective here is that students learn about threat intelligence, about mapping, about identifying patterns and trends, and also about mitigation. So these are our efforts in the education space. I'm now going to pass it on to Rachel to talk about what we're doing for the data sets. So Rachel.
Great, thanks, Anshul. So through our Cybersecurity in Action Research and Education Lab website, which is sites.temple.edu/care, we offer free downloads of the course projects along with 2 data sets that we've created and have recently mapped onto the MITRE attack framework. Both of these data sets are updated on a monthly basis. The first data set we have is a repository of social engineering incidents. We currently have 623 incidents recorded spanning from 2011 up through August 2020. The second data set consists of ransomware attacks against critical infrastructure, and this data set has 747 incidents ranging from November of 2013 up through September of 2020. All of the incidents that we gather for both of these data sets is completely based on publicly disclosed information that we collect from Google Alerts. And a couple of months ago, we received some feedback from people who use the ransomware data set, and they asked if we could map it onto the attack framework. So we did that, and we decided to also map the social engineering data set onto the framework as well. So on the table on the left here are some of the variables that we record in the social engineering data set, including dates, who the target is and where they're located. what social engineering tactic is used, the monetary cost of the attack, who the attacker is, and some information about the ploy of the attack. About 50% of the social engineering tactics in our dataset mapped onto the attack techniques or software. The primary techniques we were able to match were phishing and spear phishing, but there were also some instances of malware that mapped onto software in the framework. And then we also mapped about 23% of the attackers onto the attack group/attacker. So group 32, or Lazarus group, appeared several times and was the most common, while groups 59, 92, and 94 were also repeatedly mapped. Moving on to the critical infrastructure ransomware dataset, our variables record information about the date and location of the attack, who was targeted, what strain of ransomware is used, and details about the ransom. And in our transition from the 9th iteration to the 10th iteration of the dataset, we began mapping onto the attack framework. We first removed all incidents where the strain was recorded as NotPetya, as the attack framework defines NotPetya as a wiperware and not a ransomware. We then mapped the ransomware strain variable onto the attack software ID. About 56% of the strains mapped onto the attack software. And these 8 softwares are the ones that appeared in our dataset repeatedly and included Maze, Locker Goga, NetWalker, Ragnar Locker, Robinhood, Ryuk, SamSam, and WannaCry. And we did experience some challenges and found some limitations with mapping our dataset onto the attack framework. In the social engineering dataset, many of the social engineering tactics do not currently exist in the framework, such as whaling and vishing. And while our mapping results did show that about half of the tactics mapped over, the bulk of our incidents in this dataset are phishing and spear phishing attacks, which the framework does include, which raised that percentage for us. We had very few techniques besides phishing that mapped onto the framework. And in the ransomware dataset, we were unable to map a portion of the strains. Some strains that appear frequently in the dataset, such as Revil, and has been around for some time, do not yet exist in the framework. And other strains that are newer, such as Ransom X, are also not yet in the framework.
Great, thanks, Rachel. So I'm just going to bring everything to a close here and share with you some of the reasons why we're using this, right? In the education space, I, as an educator, certainly found pre-attack to be extremely useful because it helps our students develop the ability to map and understand threat intelligence, and also the ability to understand challenges and limitations. I think what's really cool is we're trying to map social engineering cases, which is not typically done. So I think that's an interesting exercise in and of itself from the social science perspective. What I also like about this is it isn't technical enough, so all disciplines can engage. I have a lot of social science students who can actually participate in this and get a top level understanding of threat intelligence. So I think that this is a really, really cool exercise for my students to try out. From a data set perspective, interestingly, when Rachel and I started this, we were struggling to get data because for obvious reasons, companies don't want to share it or government doesn't want to share it. So we said, you know what, let's create our own data set and we'll share it with other folks in the academic domain. And so we've had a lot of educators and students, of course, request this data, which was great because it allowed us to fulfill sort of our objective of sharing this with the wider academic community. But interestingly, we got a lot of requests from governments, not just in the US, but around the world, and also industry from all over the world that was interested in getting a copy of our data set. We said, hey, let's see if we can look at trends and patterns across ransomware strains, comparing the data to their own internal data sets, raising awareness and for training. And what was really cool is mapping it onto MITRE really improved the quality of our data set. It gave our data set a lot of credibility. And we got a lot of responses saying, thank you for mapping this. This is going to help us out big time. So that is, and the really cool thing is it was after we mapped it onto the MITRE framework, we actually got, the data set was actually picked up by Security Week and also mentioned, our lab was mentioned in Leaping Computer, which was, again, another big win for us because we're a team of 2 trying to do something like this. And it's lovely to see that our efforts are having an impact and benefiting the wider community. So one of the things that we want to do is, like I said, we're aware that pre-attack and attack are going to be restructured, merging. And I know that pre-attack and attack has helped me in the social science space, right? Helped me with my education and research efforts. What I would love to do is to see how we in the social science domain, through our education and research efforts, can contribute back to pre-attack and attack. And this is what our previous speaker mentioned as well, is how can we be contributing? We're trying to create data repositories. I remember, where do we go to get data, right? So we're looking at indictments, we're looking at social engineering case studies. We can conduct focus groups and interviews with social engineers. And we're also trying to weave it into what we've just started at Temple, is a collegiate social engineering capture the flag competition and training event. So can we use MITRE's attack frameworks to sort of shape that exercise, and in turn use student experiences to then contribute back to this framework? So if anyone's interested in any of this, we are definitely seeking collaboration. We'd love to hear not just from academic communities, but also from industry and government, and of course, MITRE. So that's everything that I had. We can, I guess, take it up for questions.
Fantastic talk, and like people are going nuts over this data set. And like I said, I love that you touched at the end of like how it was truly a grassroots effort to compile that and build it yourself. I think the biggest question is, like you said, I love the idea of, like you said, no matter how technical things are, there's a human element to all this work. So my biggest question is, have you seen themes in terms of the mitigations that your students are putting together for these attacks that you can share with the wider community, the things that we can do to kind of prevent, or at least mitigate to some degree these layer 8 human-based behaviors?
Yeah, that's a great question. And, I'm going to respond in two parts here, I guess. One is it's primarily been policy, appropriate behavior, what to click on, what not to click on. So a bit more on the education and training aspects of this. But I love that because it's a multidisciplinary class, you're getting computer scientists to really think about this, right? This is the next generation workforce of computer scientists who are going to be developers and defenders. And so thinking about using these frameworks, not just in the technical aspect, but also on the human domain, right? That curve, I think, is really getting them to think about that as they go out and design and defend systems. So that's, I know it's impossible to really give your question an effective response in the short time we have, but I'm happy to carry on that conversation in the Slack channel.
It makes a lot of sense. Like you said, you can only build a wall so strong if someone's just going to open the door. What's the point? But yeah, with that, thanks again for a great presentation. That was really excellent. Like I said, there's a lot of Slack activity going on, so definitely hang around and ask some questions. But
great, thank you all.
With that, I'm going to turn it back over to Adam to introduce our next speaker.
Yeah, and along with Jamie, thank you again. Awesome talk. And so time to go on to our next speaker, though. So next speaker is going to be Matan Hart with Symptom. And if you're ready, take it away.
Thank you, Adam, and the entire attack team for having this, giving you the opportunity to present. You're doing an amazing job. Huge fan here. Great. So I'm going to talk about today is how you can transform adversary emulation into a data analysis question using the MITRE attack framework, and specifically the mitigation in the attack framework. About myself, usually I look like in the picture on the left side, but during COVID, I might look like this. I'm a co-founder and CEO at Symptom, security startup specializing in security testing. I've been a security researcher in the Israeli Defense Force, and as well as in the private sector. Some of my research I've been presented in several security cons, such as Black Hat. And actually, the inspiration for the content that I'm talking today is based on my existing work building solutions and conducting security assessments for large organizations. And click. Great. So let's start with adversary emulation. Other side, I have an issue with the clicking. Great. There is a lag a bit. Sorry about that. So adversary emulation, for those of you who need a recap, is the way that has been used popularly, one of the most useful use cases for the attack framework, which is basically allow the organization to test their defenses against specific threats. The attack framework can be very beneficial to measure, test, and then also make improvements to defenses based on the different adversary tactics, techniques, and procedures. But the problem with adversary emulation is that it doesn't scale, nor it wasn't intended to. Basically, the main focus of adversary emulation is to test specific controls in a controlled manner that is very targeted specific network and emulating a specific threat. The issue with it is that some organizations are still early on during their work with the attack framework, and they basically want to get an initial state of where they're standing with their defenses against the metrics. And what I've seen that basically some organizations are trying to emulate all attacks, all in the network. I've seen one time that there was an organization with 50,000 endpoints where they needed to emulate a lateral movement technique used by an APT, and they figured out only where after they used some kind of automation that they literally emulated 2.5 billion emulation, because they tested it from each computer to all of the other computers in the network. So it was a big number, and it's actually made a huge disruption to their network. So what I'm suggesting is to a different approach using the MITRE ATT&CK matrix framework that basically instead of checking detection capabilities that are the most commonly used with adversary emulation, is to basically look at the aspect of the mitigation of the attack framework and testing each technique and the associated mitigations if you really have the right capabilities to prevent this technique before going on to detection. So the methodology is have 4 steps. First of all, choose an attack technique. You should preferably choose the technique that you feel more you want to have the first initial, that you feel comfortable that you want to test first. If you're already mapped techniques to detection capabilities, so you should preferably start with something that you feel that you don't have enough data sources or detective capabilities in place. Then for the technique that you choose, you should test for each mitigation how much it's effective, because not all of the mitigation that are in the attack framework are having the same they're reducing the same attack vector. Some of them are just reducing some of the attack surface or the exploitability of that technique, and some of them are truly mitigated the technique entirely. After you grasp those techniques that you want to focus on, you should map the data sources that you can really collect the information needed in order to validate the applicability of that mitigation. Preferably, you should do it for all the mitigation for that technique in order to make sure that you're not missing any information. But in generally, as mentioned also by previous speakers before me, it's not science, the attack framework, and you don't have to be 100% all the time. And it's okay that even if you feel that it's not 100% accurate or don't have access to all the information, you can still be able to have the initial states to conclude if a specific technique you are able to prevent in your what is your current situation with that technique, and how much is exploitable in your network, not on specific endpoint, rather on the entire attack surface inside a network. Let's take a test case, the pass the hash scenario. Basically, pass the hash is a lateral movement and defense evasion technique that allows an adversary to move laterally between endpoints based on credentials that they can reuse, because those two users have the same credentials, It's very common between endpoints that are used by the same image, and the default built-in users are, their password are not changed after they've been deployed. And something that is still very common to see in organization, and it's something very hard to really know what has been changed or not. When we're looking at the mitigations in the attack framework about this specific technique, there are basically four different mitigations that offer different. They have different ways to mitigate this technique. However, not all of them are actually doing the same, and also their exposure that they are reducing or eliminating is not the same. So when you drill down with the small letters, first of all, you can understand what is really need to be checked, what data should be collected, and then you can move on to do a bit of research. It's not something that is very easy, but we took here a case that is more harder. There are some that the mitigations are more straightforward. But when you check each mitigation specifically, you can see that their effectiveness is not always the same. So of course, if you have the capability to check if there is any type of credential overlap, the first mitigation, which is privileged account management, if you use labs or you have access to endpoints and check the registry, or whether you have a PAM solution that you can use to assess, this is the best mitigation that you could check, and you could also enforce. But of course, life are not perfect, and if you're looking for other mitigations that could potentially reduce the attack surface, you should consider checking for your patch management, if you install the right patches that the MITRE mitigation suggests, as well as which will mitigate the exposure only to administrative local accounts. You could go with the user account control mitigation, which is aimed more for domain users, but it could be easily checked by checking the Active Directory in the GPO to see if there is or users that have multiple systems that have administrative access, that the same user have this administrative access to both of them, and maybe you should consider focusing on that mitigation as well. Other effective mitigation that is being used in the frame that is commonly seen in organization that is easy to implement is the user account management. Is basically enforce some UAC restrictions using the GPO. If you don't trust your GPO, you could also, if you have the capability to query each endpoint registry and look for the right keys, which are also mentioned in the MITRE mitigation, in the attack mitigation. And basically, if you don't have, if your built-in administrator account is disabled, this is a very effective mitigation to eliminate the local variation of local account variation of the pass-the-hash attack technique. And of course, you can do a talk about the attack framework and not show a fancy heat map. So here is my heat map. What we focus here, which is the important difference, is that we are not mapping detective controls. We are checking only if the existing mitigations are applied. So if you already built a heat map that shows your detection capabilities, this heat map could look very different. And I suggest to use it as a complementary to the techniques that you feel that you don't have enough detection controls. If you don't have already and you want to focus and you start we start from square zero, I feel it's better to start actually with this heat map. And then if you feel comfortable with preventing some of the attack techniques, you should focus your detective controls for other techniques in the MITRE framework. So those you can build even interesting attack heat map that contains how many of the techniques you are able to prevent using preventing controls using the mitigations in the attack framework, and how many of those you only able to detect. So it's interesting use case to know to make a defense gap analysis first with mitigation and then also with detection. So it's important to mention that there is no you need to pick the right tool for the right job. Adversary emulation is great. I've been doing it also for years. It helps organization really to know really where they stand, and it also check how your also people and processes are performing. The issues that that makes adversary emulation to not to scale is the potential business disruption that it might create, and also the experienced team that that should do it in a safe manner. Data analytics, on the other hand, could be a good complementary to first get the right coverage in the attack framework, as well as the network coverage in a safe manner that could scale better. I suggest to start with data analytics if you don't perform adversary emulation yet, and then based on the results that you can map from the attack matrix in order to check your detective controls, or to see how you can really check that the mitigation that you've implemented are performing as intended. Adversary simulation could be a good use case to check this. The issues with data analytics is that, first of all, it doesn't check detective controls, which is of course one of the main use cases in that people use the attack matrix, the attack framework, and it doesn't really check any type of processes. To conclude the presentation, first of all, adversary emulation are great, they're important, and it's something I suggest everybody to practice, even if you're not in the red team. Also, blue teams can use the atomic red team, which Brian talked about, but as well, it's something that you should use cautiously. It's something that you don't really want to run it in all your network. Rather, you want to do it specifically to check specific controls and in a control environment. Data analytics, on the other hand, could be a better approach to get the initial state of where what is your defense coverage, and to know where you stand, and then you could operate and implement new capabilities, whether preventive or detective. And I found the mitigation in attack very beneficial to understand what is defense coverage, because first of all, most of the techniques in the MITRE framework, and basically most of the controls that most organizations have in the organization, are first of all preventive, and of course should be preferred. So I found the mitigation in attack something that is not should be used more often during any type of usage for the attack framework. So that's it. We're not Brendan yet.
Yes. Great talk, Matan. That was fantastic. I really loved. Someone dropped a comment in Slack that you're effectively emulating the adversary emulators, but like you said, getting ahead of them and saying, before we even if we don't have resources to do an emulation, or before we do it, let's go ahead and figure out what are we doing in terms of the mitigation aspect, where I think a lot of people really appreciate, and that resonates with them. Biggest question though, I think a couple people are already asking this in Slack, is what advice do you have for the community in terms of the process that you shared of, looking at attack, seeing the mitigations for a technique, and actually translating that to, what can we do in our environment? How does that line up with our technology? What any words you can share with the community, and any wisdom you can kind of bless us with there?
Great. So first of all, I think, as also discussed in the previous talks, and I guess it's something that we learn with attack on a daily basis, that it's the human aspect. You can't really automate everything, and there is a magic. Of course, you should, it requires research, it requires work. I took an example, the pass the hash, because it's an interesting case and it's a bit complicated. Of course, some of them are much easier to start with. But yes, the process is to research, is to learn, and to be familiar with the different tactics and techniques, and to be able to really understand and research what are the current capabilities that people have in this organization that they can really check. Of course, good cyber posture and hygiene helps. And if you have the right tools and the right controls, or use vendors that help you automate some of the stuff, it could be easier. But for most techniques, I found it that it's pretty trivial. I do think that it's part of our work as a community to also invest in the mitigations in the attack even more. I know that those are also now the shield, and of course we're going toward how we can all as a community be able to share more and make that process easy.
Yep, love that answer. Like you said, cybersecurity is hard, but I'm loving the contribute plugs. Like I said, by all means, keep contributing back to us. We love it. But yeah, thanks again for great talk. And with that, I'm going to turn it back over to Adam to present our next speaker.
Yeah, and Jay, are you ready to share your screen? Yeah, there we go. So next up, we have Jair Santana from Northwave.
Okay, can you hear me? Okay. I cannot see myself, but I believe that I'm appearing there. Now I am there, shining. Okay, so guys, let me introduce first myself. I'm Jair. Actually, the full name is José Jair Cardoso de Santana. But let's keep short, Jair. I'm a cloud security lead at Northwave Security, a security company in the Netherlands. And I'm also assistant professor at the University of Twente. And you understand why I emphasize that. So I need to talk first about the problem of static threshold. Yeah, so let me give one example and I need your help, okay? So how much milk should I give to my daughter? Yeah, so I have 1.5 years old daughter. She usually drinks, or we usually give to her 180 ml 3 times a day, 30 days. So per month we spend we buy 17 liters of milk. But then I noticed that sometimes she drinks everything and seems that are still thirsty. And sometimes she doesn't finish her bottle, obviously. And my wife used to say, well, better to put more milk than let her thirsty. Do you agree? Well, to me, it's not like that. I'm a data-driven guy, so I just ask her to give 200 ml of milk. And then we count how much milk she drinks every day during the month of August. On average, she drank 172 ml per time. The minimum that she drank was 97, and the maximum was 200. Wait, we gave 200, she drank 200. The mean, I could say something, nothing. That she just drink this on average. The 97, if I look to the graph, looks a pretty clear abnormal point. Yeah, and if it's 200, well, possibly she was thirsty. Then my question comes to you. How much more should I put on her bottle? Yeah. And then I said, first I need to explain something. That is what I explain to my students. That is the quantiles, percentiles, quartiles, median. So I'll bring you back to the school, okay? So here's the graph. And here are all the points, okay? So all the amount of milk that you drink, I just sort all the values, okay? Now, if I divide this in the middle, let me ask you which element, so which number is at the middle of the second list? And then you look to the list and say, looks like that is the 180. This guy is also called as 0.75 quantile, 75% percentile, or 3/3 quartile. But the value is 180. So if you look to the second or to the first part, and I ask you what is the element at the middle, you would say 156. And indeed, and this is called 0.25 quantile, 25 percentile, or first quartile. And then if I ask you which element is at the middle of this list of values, you'd say, Jair, there is not one single element there, but it's somewhere between the 176 and the 177. So why not to have this as the median? And this middle element is called median. Ah, okay. So far, so good, I hope. So there is another concept that is really important for me to explain the rest, that is called interquartile range. That is basically the difference between Q3 and Q1, okay? It means basically what is the difference or which range of values are between this quartile and the top one. And then came this guy called John Turkey, not Turkey. And then he said, well, let's define a range to see how much this value would variate, okay? And then he said, well, if I would like to analyze the lowest point, I will take the Q1, and then I'll take the interquartile range, multiply by 1.5, and subtract this to the Q1. And he also proposed a definition of the higher value. That is, take Q3, take this interquartile range, this difference, and then multiply by 1.5, okay? This was called Honus significance difference, or Turkey's test, to define this up and down value. And then came this visualization. Who of you knows what is this visualization? Yes, it's a box plot. What you may not know is that the third quartile is this value, the second quartile is the middle, the first quartile is this, the difference in the box is interquartile range, this is the lowest value, and this is the upper value. This is the moment that usually my student says, ah, this is what the box plot means. Yes, and these values below are actually the abnormal points, okay? And I put something at the corner. This is not a normal distribution. For this reason, the values may be different. So if you remember, I asked and measured everything in August, and then I saw that I gave 200 mLs, but she reached the 200 mL. So thirsty, possibly. But after I did this Turkey test, I just took that value, the upper value, and then I asked my wife, please, let's give only 236. And then this is the graph of September. The max, so the maximum that my daughter drank in all this month was 217. Question, is she thirsty? Was she? No. Is it clear so far? So it means that instead of that 17 liters, it's better to buy 20 liters and guarantee that she will not be thirsty. And I could do this further calculation of the turkey test per month, or I could do per day, or I could do per feeding, compare it to some past data. Is that clear? I hope so. Now applying to attacks. So if you just now take this graph, I remove, and I tell you that this graph had a peak right now. And I say that this graph represents the number of sign-ins of a user per day. And then you look to the graph, look to the peak and say, well, if this is the amount of sign-ins per day, what we have here is a huge peak of sign-ins. Well, I know this guy. This may be a brute force because this abnormal point there is clearly a brute force. Or I just need to further investigate. If I tell you that instead of this graph being a sign-in frequency, is a network traffic, from one IP sending traffic outside the company, and you see this peak, you say, this could be some type of exfiltration. And if I tell you that this graph is the DNS traffic, is the DNS request towards one domain name, you could say, well, this could be a command control communication. Did you get the point here? Is that you just need to use the Turkey test to compare that point to previous points or to a previous number of points. Is that clear? I hope so. Now I need to introduce Sentinel. Who of you have no clue what is Sentinel? Maybe Mehmet has no clue. Sentinel is the SIEM, the Security Information and Event Management from Microsoft. Cloudborne offers UEBA, that is the behavior analytics and automatic response with SOAR. This is how it looks like. And Sentinel is for free. You just need to pay for the data that you need to ingest there. Okay, joke. So why I like Sentinel, first of all, is that you can integrate all the Microsoft stuffs. Duh. Well, if it's Microsoft Think, it's supposed to integrate Microsoft Think. So, but I don't want to go there. It goes beyond. Yeah. I discovered working with Sentinel and my team of engineers that we can actually onboard any type of data from any type of security or non-security box. Okay. So let's say now that I can put inside Sentinel the identity management with the sign-ins logs, remember? Or the firewall logs, or the DNS server. So what I like the most about Sentinel is the flexibility. Because I play with a lot of SIEMs and we cannot write everything. There are predefined templates that, well, no. So I'm a data-driven person, so I want to use the data as I want and not as someone says for me to do. So this is where we can use the language defined by Microsoft, that is the KQL. And then when I start learning Sentinel and teaching to my team, I saw in the documentation that there was a function that implements exactly the Turkish test. Nice. So remember these attacks? This is what the KQL looks more or less like. So this is in production KQL. So basically, I receive firewall log data using syslog. I make a series, okay? And then I just get that series and use the function to calculate what is the test of Turkey. And then I can see which values are higher than 1.5, okay? That 1.5 times the EQR. So basically here, I just use one internal IP address communicating to an external IP address with some abnormal amount of bytes sent in relation to the past. But I need to tell you what are the problems. How should you fine-tune, yeah? And how can you bring this live? Because I usually recommend for you first, before bringing it live, to test over the data. If you do tests with the data that you have, you will notice that these type of graphs will appear. So something that was, imagine that is outgoing data from one single IP to external IP addresses, okay? And then this IP address was almost no activity. And suddenly there is a peak, yeah? When I ask the analysts in the SOC if they should trigger one alarm, they say, of course, yeah, I see clearly in the graph, there is a clear peak. But then to consider this exfiltration, I need to know how many IPs these internal IP are communicating. If it's one, two, many. If there are many, I don't know if I would consider exfiltration. So then the other question is that if I run this over and over my past time, I don't know, yesterday, the day before, or 1 hour before, and so on and so far, do I notice this behavior again? And in one of the cases, one of the customers, we noticed that over time, some IPs start having this peak, yeah? And then I asked them, well, I sent a list of IPs and said, well, these IPs have abnormal behavior, and we noticed at this time, this time, and this time. And then they said, Jai, these list of IPs are behind NAT. So every time with the DHCP, someone receives a new IP, And then a new IP start exchanging data. Okay. Another customer, we see this behavior and there were some peaks. And then we asked, well, we did the test, sent to the customer, and he said, Jay, this specific IP is over and over every Monday doing some backups. Okay. And if this would be a DNS analysis, or the DNS queries to a specific domain, well, this is normal. It's like I tell you now, I tell in the chat what is my web page, and everyone would access that URL. It means that the number of DNS queries generated within the company would be big. The question is this the normal or the abnormal behavior? Well, in this case, it may be normal and not a command control communication. So all these nuances you need to fine tune with the customer. So before you bring live, test using as much data as you can. I tell my engineers to run 10,000 times the same algorithm. Just create a loop, go back in time, and leave the algorithm running for the entire night. Give me the data and let's contact the customer to clarify, to fine-tune your algorithm, to add which IP should be removed or which IP should be, we cannot use blacklist, whitelist anymore, but okay. But yeah, remove or include, yeah, to be more whatever. And then after you create this list, you can bring your algorithm live. Looking to the feature and checking my time here, as I'm almost there. Basically, what I'm doing with the academia, with my students, is taking the entire list of Maitri, and then we are going one by one there and try to create a signature-based rule using KQL. And then in a second stage, we do the same thing using statistical methods, like the Turkish test. But we also use some machine learning algorithms. And then the KQL, you cannot write a machine learning algorithms, but Sentinel allow us to use Jupyter Notebook. My life is saved. Now we can bring all our crazy machine learning algorithms to use the data within Sentinel. Now, guys, let me go. My little one wants the 217 of milk or less. Thank you very much.
That was fantastic. Thank you. I think the theme of the day is the human connection to all this. So thank you for bringing your family as well as your great insight into the presentation. We really appreciate it. So definitely hang around and ask some questions or answer questions in Slack. But I think we ran out of time for any live Q&A. So with that, just want to thank you one more time and pass it back over to Adam to introduce our next speaker.
Yeah, and hopefully we can get switched over to Brandon's slides back to the main deck. There we go. Excellent. So we're coming into the home stretch now. Just got 2 speakers left. And so going to turn it over to Brandon Levine from Google.
All righty, let me make sure I can actually click on things. Maybe. Oh, wow, that's a lot of lag. Hello, everyone, and welcome to ATT&CKcon Power Hour. My name is Brandon Levine, and I'm with Google Cloud's Threat Intelligence Team, Uppercase. Today, we'll be discussing a threat group known as TA505, thanks Proofpoint, and exploring their big game hunting operations in the context of their TTPs. Maybe. Come on. Hey, Tom, do you want to progress them? Okay, never mind. Targeted ransomware deployments are the new scourge of enterprises across the globe. The shift to ransomware as a primary monetization scheme provides tremendous benefit to threat actors who no longer have to write off upwards of 70% of their profits via a complex network of money mules and laundering. In order to maximize return on investment, threat actors now accurately orient themselves to their targets in order to identify those that are capable of paying. This means businesses, governments, municipalities, schools, and hospitals. This talk will be broken into 4 parts. It'll be context and background, threat actor processes, operational details, and lessons learned and takeaways. Let's begin with some context and background. They are a customer of Dridex, a banking Trojan, and users of broadly targeted ransomware families such as Locky between 2014 and 2017. They are not the developers of these tools. That would be Evil Corp. Thanks Intel 471, Proofpoint, and NCC for that disambiguation. TA505 moved on from bespoke banking Trojans and non-targeted ransomware in 2018. They begin to favor more traditional backdoors for achieving access into targets of opportunity. Threat actors iterated rapidly in both its initial loaders and secondary payloads. By late 2019, they settled on solely in-house tooling. They've been using the Clop ransomware family since February 2019, and there don't appear to be any other users, so it's suspected that this is an in-house ransomware family as well. Since 2018, TA505 activity has led to multiple high-profile victims in the Netherlands, Germany, Korea, and more. Unfortunately, headlines really do tell the tale here. Ransomware plus data leak is a very strong threat, and it is a natural pair. With some background out of the way, let's move into what TA505 looks like now. So credit to the French National Cybersecurity Agency, ANSI, for creating a great visual representation of the initial intrusion TTPs for TA505. So TA505 generally follows a well-established pattern in their initial intrusion process. This is composed of roughly 5 or 6 steps. A phishing email, social engineering, no exploits, user intervention is required here. That attachment or link in said phishing email, which then redirects to a legit but compromised domain, typically WordPress. That compromised domain redirects, usually with some embedded victim verification logic, aka a gate, much like an exploit kit, to a malicious domain. And finally, that malicious domain drops an Office document with embedded macros and binaries, actually. Again, user intervention as required. Just to reiterate, this diagram is only covering the initial efforts that TA505 goes through just to land on target. So now that we have a good understanding of the multiple intricate steps TA505 goes through to land on target, let's take a deeper look at how this activity actually looks. Here's the first thing a target will see from TA505, starting from the left. On the left, we have some German language spear phishing email. This is fairly recent with an HTML attachment. If anybody wants to translate what this says, I don't speak German, so feel free. On the right-hand side, we actually have the contents of the HTML phishing attachment that show an embedded link with a fake error and various non-essential padding. The only part of this HTML file that matters is that embed source equals sign, and that is pointing to a compromised but legitimate WordPress site. Apologies for the delay. After a user interacts with the spear phishing attachment and goes through the entire redirection chain in the browser, a malicious document, typically a Microsoft Excel file, is forced downloaded to the user's machine. The user must then click on this very enticing file and enable content macros, which require 2 clicks in modern versions of Office. I believe starting in 2016, but I'm not sure when that actually started. The lore documents have undergone various degrees of iteration to try and trick users into allowing macros. On the left, you see one of their earlier examples. On the right and in the middle, you see a more sophisticated social engineering lore, but the point is the same. The user must click at least twice at this point in order to get code executing. Thanks to Hatching Triage for the lovely sandbox report here. When a user allows the macros in the XLS document to execute, 2 DLL files are written to a folder in the app data directory. These are a 32-bit and 64-bit version of the same tool known as Get2Loader. This is TA505's downloader of choice that appears to have been developed in-house. Once the DLLs embedded in the malicious XLS document are written, internal logic of the macro determines whether to execute the 32-bit or 64-bit version based on the operating system. The selected DLL is injected into the already running Excel process in order to beat traditional detections that rely on parent-child oddities. We can see in the top photo, Excel connecting to an external IP as a result of the get2loader DLL being executed and injected. The bottom image shows the HTTP post body, which has been SSL decrypted, that is sent back to the attacker's command and control. So we see things like computer name, username, OS. It believes the architecture here, so it's x86, and a process list. So not everyone will get this step, depending on what is sent back in the HTTP post body of the get2loader callback. The threat actors can decide to push an additional payload, which is their full backdoor, known as SDBbot. In this image, we see SDBbot establishing persistence by writing code to the Windows registry and adding an image file execution option to winlogon.exe. This ensures that the malware executes on every startup. While SDBbot is the main backdoor tool used by TA505 at this point in time, the threat actors, when opting to interact with a victim manually, will typically use a more interactive implant such as TinyMet or Beacon. In this image, we see a signed TinyMet stager stub, which is used for pivoting inside a victim network and for various reconnaissance activities, including mapping permissions groups and privileged users. Many organizations assume that a signed binary is an indication of trust. That is false. A signed file simply means it is cryptographically intact. So you could have cryptographically intact malware, which is what you see here. And finally, we come to the end game. When a victim is considered viable and the manual recon and staging is complete, a ransomware payload is deployed, most typically CLOP. Here we see an example ransom note written as a simple TXT file, which pops up on the host after encryption has finished. This is a pretty typical ransom note that requests the victims contact the threat actor for payment and negotiations. Interestingly, they do not appear to set up accounts per victim. I don't know if that's still the case. I believe it still is, but this can actually be noted in one of the later points in this ransom note. As a small bonus, TA505 is one of the many big game hunter threat actors that uses the threat of data leakage as a strong arm tactic to entice victims to pay a ransom. They threaten to publish files on a dedicated leak site in the event a customer does not pay. This tactic has been adopted by many ransomware families and has been devastatingly effective. This has not been mapped to MITRE ATT&CK yet, but I am going to work on actually getting this particular technique mapped to the impact section. Now that we've seen a high-level example of the way various TTPs fit together, let's discuss what can be learned by studying this threat actor. Complementing defense in depth with detection in depth is crucial to protecting a modern enterprise. Studying TTPs with an eye towards interdiction opportunities. Where should I see X? How could I stop Y? Should be your organization's plan when considering how best to use MITRE ATT&CK. Detecting the ransomware is too late. A long chain of activity preceded the ransomware deployment. And finally, attackers use a blend of tools and techniques. Open source or red team tools on GitHub are no less capable of getting the job done and are arguably a higher ROI and significantly more accessible. Thank you, and I'll hand it back to Jamie.
Awesome. Thank you, Brendan. That was fantastic. And I think one of the unintended, unplanned themes of the day was the human behind the keyboard and how much that plays into these attacks. And I think your presentation here really kind of highlighted that with the optimistic nature of it. It's the initial access that you went through was all based on users, clicking things they shouldn't, enabling things that, otherwise, defenses otherwise would protect. But what are your thoughts on, as a community, what can we do in terms of, minimizing that? So like you said, the full chain of behaviors that kind of spun from that one bad decision, what can we do as a community to kind of minimize the impact or the likelihood of that?
So I think really one of the main takeaways for me is that studying the way the TTPs fit together is of paramount importance. And we've sort of espoused this idea of defense in depth, but that hasn't really kept pace with the concept of detection in depth, wherein you need to consider, how can I see this? Where can I stop that? And how can I stop why? And those are really critical questions to consider when creating a detection program. And MITRE ATT&CK is a great guideline to help inform those sorts of decisions. As Brian mentioned earlier in his talk, there is a lot of art behind the science, and a little bit of science to the art. But I think it is really important to understand how the big picture really fits together, because, you know, when you start to try to detect just that ransomware, you have missed, you know, 5 or 6 different interdiction opportunities.
That's a great point. So like you said, plan for the best, but assume the worst, and kind of like, you know all the steps along the path that you could possibly interject and have a detection opportunity. It's really great advice. Thank you. With that, I'm going to obviously thank you for your great presentation. Thank you for your time and sharing with us, and then hand it over to Adam for the introduction of our last speaker for the day.
Yeah, thank you, Jamie. So our last speaker today is actually going to be someone from the ATT&CK team. Going to be switching to Jen Burns, who is the lead for ATT&CK for Cloud. Take it away, Jen.
Sure, thanks, Adam. And hey, everybody, I'm Jen Burns, lead of ATT&CK for Cloud, like Adam mentioned, and really excited to talk to you all about what's new and upcoming in this area for ATT&CK. So to give a bit of a background on ATT&CK for Cloud, it was actually at the first ATT&CKcon where Dave Harold and Ryan Kovar presented this slide that I graciously stole from them and can't take credit for. In their talk, they expressed the need for expanding ATT&CK into the cloud. This also ended up, being a fairly common request from the community. So about a year ago, or what now I guess seems like about 10 years ago in COVID years, the ATT&CK team was able to turn that cloud frown upside down and add cloud techniques into ATT&CK. So ATT&CK for Cloud was added as a part of Enterprise ATT&CK. It really was and continues to be a community effort. Almost 100% of the initial release of ATT&CK for Cloud was contributed by the community. That initial and also the current release cover AWS, Azure, and GCP, as well as Office 365, Azure Active Directory, and also kind of a generalized SaaS platform. With the release of sub-techniques in July came a refactor of ATT&CK for Cloud to also add sub-techniques. With that update, we also added some new infrastructure as a service techniques and sub-techniques like modify cloud compute infrastructure within defense evasion. And we made some improvements to ensure that every technique in cloud had some sort of description on how it fits into cloud. As always, though, if you see gaps in the cloud matrices, please feel free to send us new technique and sub-technique submissions. We love contributions. We, definitely hope to just continue to work with you to make ATT&CK for Cloud as usable as possible for the community. So with making things as usable as possible in mind, just wanted to take a moment to kind of explain what we consider to be the scope of ATT&CK for Cloud as an ATT&CK team. Really, you can use ATT&CK, including cloud, in whatever way works for you. But this is how we view like adding techniques into a cloud platform within ATT&CK. One thing that we determine is if the technique is generally visible via cloud data sources. If you're familiar with the shared responsibilities model of cloud service providers, these are data sources that you as a customer have visibility into and are generally responsible for. To think of it in kind of the opposite way, the cloud matrices generally don't contain techniques that only the cloud service providers would have visibility into. We might find that there are exceptions to this over time, especially when it comes to SaaS providers. But for the most part, this is what we're scoping for. And then additionally, when we scope cloud techniques, the team works to minimize that duplication of techniques in cloud across those found in like the Windows, Linux, and Mac OS matrices. ATT&CK for Cloud is really meant to provide a separate layer of coverage of adversary behavior that's focused specifically on cloud. So for example, consider like an adversary creating a cron job on a Linux EC2 instance or an Azure VM. Even though that technique was carried out in the cloud environment, that's covered by the Linux matrix. So we generally wouldn't add that technique to cloud unless there's something that makes it specifically unique to cloud. So to kind of start digging in a bit into the future of Attack for Cloud, first thing I want to talk about is the future of cloud platforms. And as a heads up, none of these proposed changes are going to be added to Attack until 2021. We want to make sure to give you time to give us your feedback on this and plan for any of these updates. So right now on the left, these are the current platforms in Attack for Cloud. After doing some research, talking with folks in the community, we're planning in a future release to consolidate Azure, AWS, and GCP into a single infrastructure as a service platform, and then continue to add additional SaaS platforms to Attack. There are a few SaaS platforms we've been considering for potential future inclusion into Attack. We'd also be really curious on your feedback here and your in the wild experience with adversaries here, so we can kind of continue to increase coverage in this space. So some of you are probably wondering why that generalization into infrastructure as a service. Well, the first reason is that the current infrastructure as a service platforms already share most techniques across Attack. We realize there are some exceptions here, and there will be in the future. So those exceptions we plan to document in the descriptions and other fields of the individual techniques for transparency. Another reason for this change is it helps to broaden the scope of Attack across other cloud service providers, in addition to Azure, AWS, and GCP. And then finally, and probably most importantly, the community feedback we've received here favors a single infrastructure as a service platform. A survey at the EU Attack conference earlier in the year showed that many supported this. And pretty much the first question I usually get from people when I talk about Attack for Cloud is why the infrastructure as a service platforms are split out. So we're definitely interested in your feedback here, though. Please feel free to reach out once again with any thoughts you may have on this. Next thing I want to talk about is plans for cloud data sources moving forward. So right now, almost every cloud data source, especially in infrastructure as a service, is just logs. We realize that these may not be the most helpful data sources, as they're pretty general and can be really vast. So we plan for some future updates here as well. I'm not sure how many of you have seen Jose Rodriguez's blog post about the future of data sources for enterprise Attack, but we're also moving in that direction with our cloud data sources. So the idea here is that you have a single data source. It has one or more of these things called data components. And then as contributed from the Attack team or the community, there can be mappings to relevant events and APIs from the various cloud service providers and SaaS providers. We really hope to move away from that general logs approach and start moving towards something that's a more meaningful set of data sources for our users. So here's an example of what the instance data source may look like. Shout out to Matt Bajek on the Attack team who did a lot of this work. So we have the data source on the left, which is instance in this case. Then we have multiple data components that basically consist of like operations on that data source. And then you can map one or more relevant events to each data component based on the cloud service provider or SaaS provider's offerings. Obviously, we still have a lot of work to do in this area as a team, but we really wanted to get you all kind of a sneak peek so you know what our plans are here. And just to recap what we're planning on updating cloud data sources. First off, we want to ensure that we're consistent with the rest of enterprise. I do recommend checking out that blog by Jose to see what our plans are in that area. We also just want to make sure data sources are more meaningful. Feedback suggests that that everything is logs approach isn't super helpful for building things like detections. So we want to refactor to align to events and API calls instead. And also we want to ensure that our data sources approach is consistent with that plan for consolidating AWS, Azure, and GCP into infrastructure as a service as a platform. We're hoping to make the data sources and data components general enough across the cloud service providers that they're usable across all. And finally, I just want to put out a call to the community to help us make Attack for Cloud as useful as possible. First, please let us know if you have any thoughts on how we can improve Attack for Cloud. You're the ones with boots on the ground using it. We want to make sure that it works for you. Also, we need your help to continue to add to and improve Attack for Cloud. Please reach out if you have in the wild visibility into what adversaries are doing in this space, and send us your contributions. Also, if you have opinions on the future platforms or data sources updates that we're planning, please let us know. Nothing is set in stone yet. We want to make sure that these changes are what's going to work the best for you. And as always, you can reach out to us at attack@MITRE.org with any of that feedback. Feel free to follow me on Twitter at SnareGen if you like drums, cats, or Attack. And then you can follow Attack at MITRE Attack to stay up to date. Thanks.
Awesome. Thanks, Jen. Like I said, the Slack's going crazy with questions, comments, so definitely hop over there and respond. But thank you for the updates. It's really exciting to see how much cloud has gone from initial drop to, growing into where it is today and where it's going forward. So definitely appreciate your sharing all this great insight with us. And with that, I'm going to turn it over to Adam for a sign off for the day.
Yeah. And sorry, we're going a few minutes over today, but thank you to all of our speakers for coming, for making this what it was today, as well as to our communications team for all of their help putting this on. And thank you for actually joining us. There's been some great discussions in our Slack, as Jamie said, which will hopefully keep going after we're done here. We're not going to close up shop as soon as we're done. Links to videos and slides from today will be emailed to everyone who's registered as soon as we're ready to put them online. Please join us for our next ATT&CKcon Power Hour on November 12th. Registration is open today. And again, thank you for joining us.